Okay, let us see this question here. Let us go through it. It's a nice one. Different approach also. It says, a particle of mass is resting on a smooth plane inclined at this. Now, we start by putting our particle there. Our particle is here. It has a mass of 26 kilograms. Okay, resting on a smooth. The moment you hear the word smooth, it knows that we don't have any friction on this plate. So this is going to be moving freely. It's attached on the right inextensible string passing over a smooth pulley. So that we have a pulley at the edge of this. So now this is attached onto that, passing over this pulley, as you can see. Then, of course, it will go like that. Continue. At the edge of the plane, if the string is also attached to a 4 kilogram particle below the pulley, so there is a particle here of weight, okay, of mass 4 kilograms. You summarize the question it is. Below, find the normal 26 kilogram particle acceleration at the system. Okay, now they give us this angle. First of all, starting by our angle theta was given by tan inverse of 5 over 12. So from here, our tan theta, we can everything is going to be 5 over 12. So from here, we have now our angle there. Don't try to press this because you are going to get errors, some errors on approximating that value. Write them over there as questions. Okay, now if the body is like this, of course you are going to have a weight acting on that body. It's going to be 26 times gravity. Then also this one is going to have a weight, which is going to be 4 times gravity. Now, if you have resolved this one, we are going to resolve this one. It's going to be adding a normal to it. The normal reaction which is set R. And if you resolve this force, we are going to be adding something like this. And then we resolve also it like this. I think we saw this, how we resolve this in the first lesson. So this one is going to be the theta because this one is 90 and this will be 90 minus theta. Then that will be our theta like this. Because from here up to here is 90. So meaning this will be, if this one is making a 90 degrees here, then this will be theta. This will be 90 minus theta, and that will be 90. Then the balance there will be that. So this force here is going to be like that. Then this one, but you see that this one is adjacent, so this force is going to be 5. Okay, this force is going to be 26 cos 26 g cos theta. Then this will be 26 g sin theta. We are basing on this force here. Resolve this. Then so this is adjacent and this one is going to be the opposite. It's going to be like this. When you resolve it like this, the opposite, which is going to be prior to this. Okay, after doing that, now that there is a tension, some tension in this spring pulling it. If you pull it downwards, there is a tension which is going to be resisting upwards. Then, if this particle is going downwards, then there is a tension which is going to pull it up also. So, like that. Don't do these things and then you put here. What does this mean? This one is not allowed. No, not allowed. And then you do this and then you put an X in your attention. No, not allowed. Not allowed. Okay, you separate these two with ease. We have lost nothing. Okay, so after doing that, we start now. We need the cos theta, we need sin theta, so we can come and use a right angle triangle here using the trig, of course, of Pythagoras theorem. So this is opposite, which is 5, adjacent 12. Of course, this will be 144 plus 25, that's 169 square root. That will give us 13. So from here you can see that our sine theta is going to be opposite over hypotenuse. Then our cos theta is going to be adjacent over hypotenuse. As simple as that. So now you have this, you have this. Then pressing it on the calculator to get theta. No. Okay, let us get part A, the reaction. Okay, if you resolve like this to the plane, if you resolve along the plane like this shows that we are resolving like this, perpendicular to the plane. So remember, our resultant is always equal to mine times A. Now, along this, there is no any acceleration. Along this, acceleration is 0. So meaning that from here now, we shall get now R, which is going like this, then minus the opposer. This one is opposing, 26 G, then cos theta equaling to, here our acceleration is 0, along the plane, perpendicular to the plane, perpendicular to plane, no acceleration. So that's why I have 0. And so our R here will be 26 D. What is our cos theta? Okay. Cos theta, which will be 26 D into cos theta, which is 12 over 13. Okay. By this one, by this 2. So we shall be having 24 D, which we can ably, which will be the same as 24 into 9.8. If they give you, it depends on the value they give you to this D. So this one is giving me 235.2 newtons. It's a force, reaction is a force, and I understand. Okay, now what is our acceleration going to be? Now it's not this force is lighter than this, so meaning we expect our acceleration to be this side, like this. This is where our acceleration is going to be. So meaning this one is going to be pulled up because it's lighter. This one is 26, this one is 4. So it's going to be, we expect our acceleration because this one is going to be sliding downwards like this. The smooth, the plane is smooth, so we don't have anything like friction. We shall see those cases when it comes to friction. But for now, we are studying a free, a smooth surface. Now, the acceleration, let us start with this, the 4 kilogram mass. The 4 kilogram mass is that our acceleration is going upwards. Remember we said the resultant force is acting in the same direction as the acceleration to that part. The force that is causing acceleration to this particle is acting in the same direction. So going upwards, you start this one is upwards. So this one is pulling, so it will be T. Then minus the opposer equaling to the mass 4 times the acceleration equation 1. As simple as that. These are very easy things. People don't want, when you find these connected particles, just smile. They are easy. You see? Okay, when you come to the 26 kilogram mass, okay, it's now the 26 kilogram mass is going, the acceleration is like this. Our acceleration is going to be in this direction. So that is our acceleration. So meaning our FR equaling to MA, my resultant is going to be the force that is pulling this like this. I think you can see. So this one, you see this in the direction of this. So this is going to be now 26 G sine theta, then minus the opposer. We have an opposer T equaling to the mass, then times the acceleration. But we have sine theta. Our sine theta is here. So this will be 26 G into 5 over 13 minus T equaling to 26A. When you see this and this, it's going to be 2. So it will have 10 G minus T equaling to 26A. And this becomes our equation 2. Okay, after having that, I think this one is the easiest to handle. So you say we are going to add this plus this. So 1 plus 2, when we add this, we have t minus 4b equaling to 4a. We are adding on this, we start with this t, then plus 10b equaling to 26a. If I add these two, you can see this plus this 0, this plus this. See, I'm going to be adding 6 remaining d equaling to, this will be a 30a. So that now my a is going to be by 6, this will be 5. So we're going to be adding 1 over 5 d. Okay, which we can easily substitute. We are going to substitute that. Okay, now after having this, I can say from 1. Here, from 1, if I bisect, so then I say from 1, it's up to you. Either you solve them simultaneously, or from here you can help me see that your t is going to be 4a plus 4b. So your t will be 4, acceleration is here as d over 5, then plus 4d. It's easier to use before you substitute there. So our t is going to be, that is going to be 4, this is going to be 20, so it's going to be 4d. You cross multiply, you get 20. In simple terms, you are getting the LCM, the whole over 5. So my t is going to be 24. Note 24d, the whole over 5. And then from here, you can come and put your d as 9.8. So these are Newton's speeds because it's a force. So from there, we can simply say 24 divided by times. So here I'm getting 47.04 newtons. And you smile. Then here, I think that one is 9.8 divided by 5, which is 1.6, which would be 9.8 over 5. And this would be 1.96 meters per second. Don't forget to put units there. And life goes on like that. As simple as that. Unless you have a question, but that's what we have in there. So that's it, members. I think you see, the tension is going to be far bigger than this current here. So that's why it's going up like that. So that's why it's going to be pulled in that direction. As long as you know the acceleration, direction of the acceleration, life is going to be very easy. It's going this is the one, this is the direction. This then minus the opposite, equal to the mass times acceleration. That's it. I wish you well, but please don't forget to subscribe to the channel. See you there.